What if you can break an aerospace component into its minute bits and perform testing to predict how this component would behave in abnormal conditions? Now the catch is, we are not gonna touch the material, we're not gonna touch the component, we haven't even seen the component. How would you carry out this task? Well, finite element analysis is the answer. So in the next 5 to 10 minutes, I'm gonna explain how we carry out a finite element analysis, i.e. breaking down a structure into small pieces to predict how it behaves in the real world. ඉතින් අද මම කියලා දෙන්නේ aviation expert aircraft අන්නේ සබ් ඒ වීඩියෝ එකට මගේ තව ප්‍රශ්නයක් So the $1,000,000 question, what is finite element analysis, i.e. FEA? Now, finite element analysis, I'm sure you have heard everywhere in the engineering world. Have you done an FEA before? Or are you FEA competent? There are FEA jobs available. Somewhere rather along the line, you would have heard FEA being an engineer. So, FEA uses a mathematical technique to analyze and simulate a structure or a component. What in layman's term, in its simplest term, will break down the terminology itself, finite element analysis. We break a structure down to its finite elements in order to test, so we can predict how it behave in abnormal conditions or in the real world. So the above definition is simple, but let's take a real world scenario. Imagine you have a complex aerospace structure like the wing. Now FEA engineers would break this down or divide this wing into finite elements, into small portions. Now using mathematical equations and principles, these engineers can predict the stress, strain, and any deformation this structure is going through. This is what FEA is. So a little something before moving on to component thing. I'm a full-time engineer and a lot of time and research are invested on making these videos. And as I say, the numbers doesn't match up. Viewers have not subscribed to my channel. So I do please encourage you to subscribe if you haven't, and if you're new to my channel, please do hit the subscribe button and share the knowledge. We'll move to components. Now there are different components to this FEA. Number one would be meshing. Meshing is when the structure is discretized into elements. So discretization means when a model body is divided into an equivalent system of smaller bodies or units interconnected at points common to one or two elements, which we call nodes or nodal points. Then the material properties such as elasticity or thermal conductivity are assigned to these elements, and then boundary conditions and external loads are applied to these elements to mimic the real world scenarios. So now that we have a basic understanding of finite element analysis, let's look at some of the benefits and drawbacks. Number one, which is worth mentioning, aerospace industry are the first people who use finite element analysis in our work. Number two is our engineers can test the design and see how the design responds to aerodynamic forces, and they can make sure whether the structure can withstand those forces. There's a limitation though. We can't 100% rely on finite element analysis due to the reason we have limited information available. Now the information we have gathered them from our past experiences, and we have no idea what's out there more to capture. And also in the outside world, nature can play in different ways. We can never replicate that in a software, so that's a limitation. Number three is engineers can make sure whether a design component or a structure meets the safety target. So in order for a component to be fitted to an aircraft, it has to meet a certain safety target. Now, if that doesn't meet a certain safety target, it is not bound to be on the aircraft. So FAA has saved us millions of dollars by postponing the manufacturing process. What does this mean? Because in the past, what we used to do is we manufacture a component and we have the physical component on our hand, and we do physical tests to make sure that it meets with the safety targets or it is capable of withstanding the dynamic forces. But now we can stop the manufacturing process or postpone the manufacturing process, create this model inside our computers, do the testing, and we can see whether it meets the safety target. So that would be the deciding factor whether to initiate the manufacturing process or not. There are some popular softwares used in aerospace industry, namely ANSYS, Abacus, and also Nastron. So these are a couple of softwares that used to carry out FEA. I know this doesn't fall under a benefit or a drawback. We can compare different systems, but that's a different video. So this is all what I wanted to bring you today. I'll be back with another video defining something in its simplest form. Until then, keep fixing.